Greetings, friends, and welcome back to yet another edition of the Bacon, Lettuce, and Tomato Built-In Report. Up to number 10 now. We're actually moving very rapidly through the concepts, and in this session, we're simply going to focus on using class method, and more importantly, how it relates to what we've covered so far. Let me give you a little warning here. This is an incredibly advanced lesson. And the key takeaway point for a beginner is that class method works a lot like static method, except for class method has a type passed to it, or the type that is associated with the class that has the @class method decorator. Only key takeaway point, and we're going to go deep in here for those who are more advanced. So let's take a look at our help system before we understand the difference between class method, which basically will convert a function to be a class method. And once again, take that with a grain of salt, because we saw that we can indeed create a standalone function, but with class method, just like static method, we do indeed have the ability to wrapper what we decorate into the dunder func operations. So they are much the same, although the documentation is a tad confusing. Much better is it to have the hands-on experience, because the plumbing of the operation, in other words, calling the dunder func, is very clear to understand how things work. And once again, not an interview concept, nothing we need to understand besides our own edification. So let's take a look at how we would review what we're doing and how the framework works the same whether we're using static method or class method. So recall that static method can work with the standalone function, but it doesn't work as we expect because we're not going to have the dunder call to work for us. Instead, of course, we're going to have the dunder func. Same thing, exact same operations and use cases when we use a class method as well. You'll note that weird things are going on here because lambda, like any other function, won't have any parameters at all provided to it. What we'll do is get the class parameter from the implementation of the class member instance. Phew, lots of stuff going on here. Let's see if we can take it slow. So picking up where we left off, if I have my own class and I wanted to do things with it, we understand that we can have a definite pattern. In this case, we're going to use the message called default whenever we create S straight out of the box. In other words, passing through the dunder new and then passing through the init, as we see here with our default message. To understand how class method works, we first need to know that unlike static method, and as we mentioned, we're going to get a single parameter, and that is not a self. That is actually going to be a type definition for our S class. The opportunity here is to return either an instance of class, in which case we'll see our creation as being class M, or to create it with a static method using a call, which of course would use a static method invocation. Ever concerned that we have a lot of spectators here? I'd like to invite you to open up your idle session, type in this class example, and run it to confirm to yourself that we're going to see 3 opportunities when we create our class. So by way of review, and what we didn't talk about is that we have, of course, a static dunder new that is red, so we know that we're going to be hanging off of the class and no instance will be required. And typically what we expect to happen is dunder new to automatically call init. Very problematic if we want to return other creations of our class, because if we would call new from a new, we're going to get recursion. That would cause a lot of problems. So alternately, in my mind, what we have is the ability, once we start our new class, so as to return anything else besides our type that we're working with. Typically, if I'm going to do this, I'm going to avoid having new calling new, by returning another type, or usually some parent class above me, so as to execute its new and its init rather than keep on executing my own. When we execute the dunder init, of course, we have no choice but to return that self which has been handed to us, populated with all the information. And indeed, we don't return it by using any return statement. The expected result, whenever we get through a dunder init, of course, is the self, which was passed for us merely for the purposes of initialization. Lots going on here, but easy to understand. And enter into the situation having the idea of a class method, which, by the way, is going to be created with a parameter automatically provided to it, rather than self, would be the type of CLS, which is also shared the same way we would be using new. In other words, this is a new substitute which can also have other parameters and a different class type passed to us, allowing us to pick up dynamically where the static new would, of course, be working without a self. So the possibilities are endless, of course, and once we execute the function using our inborn framework, we have been matched up with anything so as to statically call, in this case, foo, providing that class that has been provided to us, allowing us to either go through a new and init process for our type, which is usually the case, or here again, be able to return any instance to any other type we want, whether it's related to us or not, using the class method creation. So the class being passed to our class method is a guideline rather than a rule, and the opportunity here would be to use our type as an object factory, not to return an instance of that type, but perhaps something else. And this is why I mentioned class method and static creations are really good for secured access to other functions. For example, when the dunder type we're using has information required to return something else based upon that secure or factorized representation being passed to our class method. So we don't have to use the class parameter. I usually do, but we can also do other things. And even more freestyle is when we get to the static method, because when our static method decorator is eventually called, we don't even have to have a class definition, which basically will allow us to create any instance we want up to and including a statically initialized instance of the class. Otherwise, once again, pretty much anything that we want. So a lot going on here with our creation opportunities as we take a look at the dunder new, the dunder init, the act class method, and the static method. And from my mind, the static method, of course, just like class method or new, can return anything. But unlike new, I can create an instance without recursively destroying myself by using any one of our decorators. And of course, with static method, although no type is provided, we can have as many parameters as we want. So the class method, once again, is going to always have our recipe rather than ourself or an instance of the recipe. And we're always going to get it, but of course, more parameters can be provided in addition to our type. And finally, we could also return anything from class method a lot easier without so much recursion problems by either using that type to create an instance, and then again, the new and then the init, or anything else we want, up to and including raising an exception or something else from an abstract framework that will have the same signature, but work quite differently if and as we require. So the pattern we're talking about eventually can be an object factory in which we have orders coming in as class members to a type being specified to class method, or doing whatever we want using a static method. But because we can only have one dunder init In Python, at the time of this recording, static method and class methods are very important so as to allow us to create and initialize our objects in any way we may require. Very simple questions and nothing new to add as we ponder the response to KA3021 on static construction, as we tell people what is the purpose of the at class method. Next, we should probably feel comfortable answering the question of what parameters do a class method decorator and the new dunder have in common. Another intermediate question covered in my book and in PyQuest, as you may expect, is KA2015, covering framework basics. We should be able to describe to any interviewer what the purpose of a framework is. Is it to 1, enforce the CRUD design pattern, 2, provide a testable infrastructure, 3, provide common code reuse patterns, 4, ensure object factory relationships, or 5, is the purpose of a framework to ensure none of the above. Another classic question, once again from the book, is in Python, inheritance is a way to 1, manage object factories, 2, manage metadata, 3, assign interfaces, 4, ensure meta relationships, or 5, none of the above. Wrapping up with our KA3025, we should be able to explain to anybody, once again, and as we've seen previously, the purpose of using an object factory, let alone the 3 ways we've discovered and discussed on how to create different versions of the same object. So thanks for watching, and we haven't really covered any more cards, so we still have 36 more cards to go before we get to the second edition of my PyQuest cards. But of course, you can go print off all of these cards as you need to and as you want to and as forever over on the GitHub project. And if you're a little confused over the answers to these questions, I would encourage you to take my training on Udemy, as well as other content providers, or perhaps grab the solutions and the walkthroughs to most of these questions as presently available on resellers such as Barnes & Noble, as well as Amazon.com. Thanks for watching. And if anybody ever tells you that they knew all this stuff without studying hard, they're not telling you the truth. So I would encourage you to take out your idle, take out your Google, and grab a tasty beverage before continuing your PyQuesting journey into modern Python.